All right, so let's talk more about consensus sequences, in this case, the TATA sequence, right? The ideal or consensus sequence here is TATAAA. And we've given 3 examples. In the first example, we have TATGAT. So it's not identical to the consensus sequence, but we're going to change it from the TATGAT to a TATAAT. And if it's more similar to the consensus sequence, then we would expect it to have an increase in the effect of transcription, right? The closer you are to the TATA sequence, the more likely you are going to be to the ideal conditions of promoting transcription. So we need to determine if that's true for any of these examples. So TATGAT changing to TATAAT. Now that 4th position changed from a G, which wasn't part of the consensus sequence, now to an A that is. So this would be considered an up promoter because we got more similar to the TATA sequence, and that's going to increase transcription. And the next one, we changed TATGAT, but we took the second letter, an A, and changed it to a T. So we went from the consensus letter at the second position to a non-consensus letter. This is going to have a negative effect on transcription because we're moving away from the consensus sequence even more. So that'd be a down promoter. And the last one, we changed the last position T to an A. So it got actually switched to a more consensus-like sequence. So this would actually be an up promoter mutation.